Hello and welcome to java9s.com. I'm Srinivas. In this session, I'm going to discuss about the Spring aspect-oriented programming concepts. The concept of aspect-oriented programming actually complements the OAD principles. Aspect-oriented programming helps to separate the cross-cutting concerns like logging, transactions, and security. To explain this with an example, let us take I have a class called bank in which I have a method known as withdraw. The actual purpose of this method is to deduct the withdrawn amount from the balance. But for the audit purposes, we will be adding the logging statements to know when this method has executed. Apart from that, the transaction statements will also get added to ensure that database is actually properly updated. Now after the addition of these lines to the method, you can see that we are diluting the responsibility of the method. This method should be performing only the withdraw functionality, but it's now actually doing some logging and also handling the transactions. So if you take these arrows as the modules, the cross-cutting functionality will cover all the application modules as a blanket. You can find this cross-cutting functionality everywhere in the application. Because of this invasive mode of the cross-cutting code, if there is any slight change that is being done to the cross-cutting code, then it might affect the other parts of the application modules, which makes the maintenance a big nightmare. So now by using the Spring framework, you can define the configuration about what advice from the cross-cutting code to be applied to the application modules and when it has to be applied. When the application is running, the Spring framework monitors the application and invokes the logging and transaction code as per the configuration. With this, the cross-cutting code and the application modules never cross each other, and there will be no trace of the cross-cutting code in the application modules. Now coming to the definitions part, to understand the AOP concepts, we need to have a good understanding of the terms like aspect, join point, advice, point cut, etc. Let me explain this with an example. Say these are the methods in the application where the advice needs to be applied. These are the points before the method execution and after the method execution. These are called the join points where the advices will be applied. Now I want to log the details of each and every method before it is invoked. So I will choose the join points that are there before the method. Next, I want to apply the transactions functionality to all the methods before and after the method completion. Here, whatever I am executing at the join point is called the advice, and logger itself is said to be an advisor. So because we are getting the code from the advisor that is getting executed, so we say it as an advisor, and whatever is getting executed is said to be an advice. And the points where I am applying the advice are called the join points, and the collection of all these join points are said to be the point cut. So if you look at the definitions, advice defines what needs to be applied and when it should be applied. So join point is where you actually apply an advice, and point cut is just a combination of the point cuts, join points where the advice needs to be applied. Aspect is about applying the advice at the point cuts. Now coming to the advice types, we have seen the definitions of AOP. Let us discuss on what kind of advices are actually present in the AOP. We have before advice, with which we can execute the advisor code before the method is invoked. After returning advice, which can be used to apply the advice after the method successfully finish its execution. With the around advice, we can apply the advice before and after the method execution. Then comes the throws advice, which can be applied to advise when a method throws an exception during its execution. Now let us understand the concept of weaving. There are different ways to execute the advice code in the AOP. The first way is to inject the byte code of the advice at the join points during the compile time. So this is called the compile time weaving. The second way is to weave the byte code at the class loading time. During this, the byte code will be injected into the loaded class to have the advice code at the join point. So with the first two ways, the byte code of the advice will be injected at the join points where the methods are going to get executed, or at the join point level. And the third way is the runtime. With this, the target object will be shielded with a proxy bean created by the Spring framework, and whenever the caller calls the method on the target bean, the Spring framework invokes the proxy and then understand what advices need to be applied for this target method, and all those advices will be applied and the real method will be executed on the target. Once the method execution is over, again Spring analyzes whether if there are any advices need to be applied for that method after the completion, then they will be executed and the response will be sent back. So this way of runtime weaving is said to be an effective way, and Spring uses this kind of weaving. I feel that weaving the runtime at the runtime keeps the bytecode and source code clean, and it's an effective way. Now coming to the point cut and advisor concept, as we have already seen that the point cut is nothing but the combination of all the join points. So we need to tell where the advice needs to be applied. So we need to give a pattern of the methods where the advice needs to be applied to. So for that we have two kinds of classes. The first one is the Perl 5 regex method point cut, and the second one is JDK regex method point cut. The Perl 5 regex method point cut is used for the JDK versions which are older than 1.4, and the second one can be used with the higher versions. And if you use JDK regex method point cut advisor with the older versions of JDK 1.4, then it falls back to the Perl 5 regex method point cut to be it uses it at the background. Now instead of having a separate point cut where it takes the pattern of the methods at which the advice needs to be applied and a separate advisor, we can have both as a one class where the regex method point cut advisor works as both. That means it understands who is the advisor and what are the patterns of the point cut. So it works in both the ways. So we will be using the regex method point cut. Now let me explain the aspect oriented programming with an example. Say we have a scenario where a customer goes to the internet browsing center, and there's a cave owner who logs the in time, out time, and also calculates the amount that has to be paid. So now I have created a class known as customer IMPL, which has the browse method, and we'll have a cave owner in which we'll have the log in time, log out time, and issue usage bill methods. Now we will take up the before advice scenario where our target method is going to be browse, and before the browse is going to get executed, we would like to apply the log in time method. That means we would like to execute the log in time method before the browse method is going to get executed. So in the before advice scenario, we are going to create an advisor class, which is known as internet advisor here, which implements method before advice. Only with this implementation, Spring Framework will understand that this advisor is a type of before advice and checks for the before method to execute the statements inside it. Now, let us see the full flow of what happens when a caller calls the proxy. Say, now I have all these three classes referred as beans inside the Spring configuration, and I have a call internet advice is also configured as a bean inside the Spring configuration. When a caller calls the proxy that is configured in the Spring framework, the proxy looks out for what target object this call has come for, and what are the methods this target object is actually implementing. So after that, proxy need to have the information of who is the point cut advisor, who can give the information of what kind of methods the advice need to be applied for, and who is the actual advisor. So it will look for the point cut advisor, where with the asterisk expression we are explicitly telling that the advice needs to be applied to all the methods of the target object, and this regex method point cut advisor will also have the information of who can give the advice. Here the advice will be given by the internet advice, which in turn is an kind of method before advice. So whenever the browse method is going to get invoked, the internet advice before method will get executed, from which we are actually calling the kf owners log in time method. Now for the configuration level, first we will be configuring all our beans as bean id is equal to customer IMPL, and all these are the classes which I have configured as bean, where in the internet advice I have injected the kf owner class so that I can use it internally. And as a second step, I am going to configure the point cut advisor, where I have given this as a bean name as a kf owner before and after advice, and I am using regex method point cut advisor. Because this is a point cut advisor, we need to give two inputs for it, which says about the pattern of the methods for which the advice has to be applied, and also who is the one who can give the advice. So here for the property advice, I am telling internet advice is the bean which can give the advice, that which I have already configured here. And then the other property is the pattern, which gives the kind of methods the advice needs to be applied to. So with the asterisk, we are actually telling that the advice has to be applied to all the kind of methods inside the proxy interface. So now the third step is to configure the proxy bean itself. I have created the bean with the name as customer proxy, and the class is going to be a proxy factory bean. For this proxy factory bean, we need to give three inputs. One is the target, so who is the actual target, and our actual target is going to be customer IMPL, and the second input is the proxy interfaces, what this target actually implements, that is the customer here. So during the runtime, the code generation library will create the proxy bean which implements the customer interface. So it pretends that to the caller that it is having a browse method inside it, whereas this will again in turn call the target's